take a look at another example of the self-organization of this material. You can see it spiraling, spinning there. And now it's just one giant spiral as opposed to the two that were in the prior video that I showed. And this due to the fact that I took out the aluminum copper. Essentially, it was an electrode, but it wasn't connected to anything that had been in there that separated the two that they formed around, and now you can see just one. All right, so Jeremiah, if you're available and able to join quickly, just to give us a little update on your transmutation results that you have gotten, which is absolutely awesome. You don't have to do a full presentation or anything of the sorts right now, but if you're around, here is the link to join, emailing you right now. Hopefully not, no worries, my friend. Okay, send you the link. It is in your email now, I believe. Yes, it should have sent. All right, so here we can see that spiral, self-organization, and let us get another one. So this one, quite fascinating as it's the original preceding to all of the videos, and it is the white monoatomic top cloudy ormus that you can see doing this double spiral action happening, and that there's the aluminum electrode I was speaking of still in there, and thus separating the two despite it not being connected to anything, just its presence causing the dual spiral as opposed to the single spiral action observed once it's removed. And I had just poured a little bit of water into the jar, which then created this reaction and self-organization of negative entropy from the charge separation in the water, and how it dissipates and self-organizes into these spirals. And so the two we just saw there of the top of the white monoatomic material, and then this video after I had poured more water into it, which disturbed some of the bottom material, then creating the denser ormus or GANS material spinning in two opposing spirals. Hey, welcome, Jeremiah. Good to have you, brother.
Hey, how you doing tonight, man?
Good, good. Much better. Got my job back, so I am happy. I am employed once more, so life is good, and I don't hate everything anymore. All right. How are you, my friend?
Oh, quite well. I'm really glad to hear that you're doing better, man. I was concerned about you the other day, and I'm glad that it worked out. I'm just stepping outside for a moment to stare into the sky and see if I can crane my neck around enough to actually get a glance at the blood moon here. It's just going past the top of my building, so I have to look at a slightly different angle for the apex. Yeah, it's definitely getting there. Like it's unfortunately going to be probably outside the range of where I can see it from this side of the building. A bit later when it hits its full apogee, but for now it's looking pretty good. So I'm just I'm going to wait a little bit longer.
You are? Can you turn on the camera? Can we share?
There's nothing really to see. I mean, It's I have to stretch my head past the edge of the patio railing in order to see it, and I don't really want to hold my phone out, like stretch it out over
no need to dox yourself live on camera either. I guess if you're showing building angles and stuff, don't need to do that.
Yeah, indeed. So there's a lot of reasons why I wouldn't do that, but anyways, now I have things to show indoors, and no, what's really recently interesting here is that I was doing these sonicator experiments, because we've heard about Ultra or ULTR, Bob Greenyer's pet project with the ultrasonic cleaning baths, and using those to sonicate the heck out of aluminum foil, and having that aluminum foil show yin-yang type of patterns and the signatures of exotic vacuum objects. But the most interesting part isn't the signatures that are left on the foil. I think that's what a lot of people, kind of stopped at when they look at Ultra. They're like, okay, so there's cool, shiny patterns on the foil and geometries, right? But no, the really cool stuff that happens in Ultra is that the aluminum foil turns into iron-rich crenellated nanospheres. And that is a transmutation process where aluminum becomes iron and also produces byproducts of a series of many other elements. So I successfully did that experiment in my ultrasonic bath quite some time ago, but the amount of iron that I got out of it was so utterly tiny and insignificant that you had to basically let it settle out for an entire day, and then you would have to go back in there with a tiny little eyedropper sucker and try to get the itty bitty little bit of grayish powder that was at the edge of the bottom. If you tapped it enough, you might just be able to get a couple particles out of there, enough to see with your naked eye. But I have another machine, and this would be the first time that I've actually really messed around with it. And I think for this, it might be best to pull out a few things here. Let me see if I can grab some stuff ahead of time, and then I'll flip on my camera. But I'll show you this insane machine that I have. Okay, yes, so please. Y'all have been to a festival or a music show or something with really big speakers, right? I'm sure most people have stood in front of a bass subwoofer. Okay, so 400 watts is not a lot of power. It's not, a massive amount of power, but 400 watts is definitely significant. There's a decent amount of energy in 400 watts of audio, and especially, if you deliver that energy acoustically efficiently, it can be extraordinarily loud. Tube amps have a particular talent at converting electrical energy into mechanical motion very, very well through their conversion stages, because the transformers that are used to impedance match the high voltage side of the tube amp to the low voltage operating electromagnetic voice coil compensate for the little differences that would normally have to be thrashed through semiconductors. So that's why the sound of tube amps is much better and the fidelity is much better, is because it doesn't inject so much clamping noise. But okay, so here we go. I've got my foil and I've got that thing. And I'm going to turn on my camera.
Very nice.
All right.
I'm excited.
Why is my camera not working?
Live difficulties, that's part of the process.
It says, oh, that's why, because I have to do that.
Boom. We got her.
That's much better. Okay, yes. So this is a probe. I'll zoom into the head there. That's the head of a ultrasonic probe capable of delivering 400 watts of acoustic energy, 400 watts of sound. Just imagine how loud that would be.
Wow.
Into a tip the size of my fingerprint. And
so I need one of these, please. Where do I acquire such device?
This one's made by Fisher Scientific. It's called a sonic dismembrator. This is the Model 500, and the dismembrator part here is, this machine was designed to basically, you are taking a small lab beaker, filling it with some biological material like cells of something that you want to test, and this thing will vibrate so hard and so fast that the cell walls will literally be ruptured. It will dismembrate the cells, removing the membrane that protects them and exposing all of their internal goodies, ribosomes and nucleotides and the DNA. So if you wanted to get inside of a cell, this device is designed to basically get you inside of that cell. But it also is really useful for turning large amounts of stuff that are in big pieces or put together into really, really itty bitty tiny amounts of stuff. So what I did is I took a piece of kitchen foil and about maybe a foot long piece of kitchen foil, folded it a bunch of times until I had it in quite a few layers that, it was a square like this big by like that big. And
Nice.
I shoved that into the bottom of a 200 milliliter flask. I filled that flask with distilled water, and then I just simply brought the probe tip right down to the point where it was just about touching the surface. Now, this probe tip moves in and out. It moves up and down like this, like a piston. So that's the direction of motion. So it produces sound waves that shoot out the tip here and go straight downwards and would hit what's ever underneath it, which in this case was the aluminum. The acoustic energy is so intense that it sends a ripple through the lattice structure of the aluminum metal, and the electrons get ripped off. When the electrons get ripped off, and keep in mind this is surrounded by water, so there is all this pressure from the water, so that it just can't send particles flying away. The water is pushing down on this reaction as it's happening, and the sound wave being produced by the tip of this is pressing against the aluminum. So the aluminum lattice is distorted. The electrons of that lattice get completely torn off, and now the nuclei of the aluminum atoms are exposed to each other, but there's still the acoustic energy being pumped in. And in addition to just the motion of the tip here that's moving up and down, it's also doing something else. It's producing cavitation within the water. Now, the speed of a cavitation bubble and its collapsing field, or the rate of the collapse, the amount of momentum in the sound wave that it will produce takes the low frequency, large displacement sonic action from this probe tip and turns it into incredibly high frequency, ultra fast impulse sonic displacement. And that impulse is so fast that it can slam the now exposed nuclei of the aluminum atoms together and start fusing them into other elements, which ultimately they tend to end up as iron. But the interesting thing is when it does this, when they slam together, they tend to slam together and form these little crenellated spheres. And the spheres can grow over time. So this I did not actually use the probe tip to jam into the aluminum. It looks like that because I allowed the probe tip to just get close enough, and the sound waves created all this crushing and all this appearance. So that's all done by sound. That was not from physical contact. And that's why the probe tip is it looks absolutely perfect, and there's no erosion on it. Now, obviously, this whole entire horn, this was used. This is a used piece of equipment. I got it for less than $1,000, and it cost like $5 or $6 new, so not too bad. But just that amount of energy can literally rip electrons off of metals. And so now I want to try other stuff. If I know aluminum turns
them together,
right? So if I know aluminum turns into iron, I wonder what bismuth turns into, or what tin, or nickel, or zinc, or copper, or who knows? What do those things turn into? And so now I've got to run this experiment in a various number of iterations and find out.
Absolutely, we do. And did you, by chance, have any of those little iron spheres available, or was that for
but it's going to be okay. So this is going to be an absolutely garbage video, and I'll try to show you. I have not refined the ones out that I just had drop out of suspension tonight during the blood moon. They finally settle down. I know the pH of that stuff is still high because the other problem with the sonicator is it will rip off any oxygens from the aluminum before it starts actually ripping the electrons off the aluminum atoms. And once you rip the oxygens off the aluminum can now start to react. And because normally aluminum would react with the oxygen in the air, it would form aluminum oxide, which is a sort of whitish colored ceramic material. Aluminum oxide is what they use in anodized coatings to harden the surface of aluminum and protect it from the elements. It becomes less reactive because it's already bound to something. But in this case, it's surrounded by water molecules, so it becomes aluminum hydroxide and binds with the water, which is actually a base. And that base is so powerful that the sonicator turns the aluminum foil and the distilled water into aluminum hydroxide, which then starts to eat the rest of the aluminum foil and generate a huge amount of excess heat. So you have to stop it before it gets too high in the pH, or before it gets too warm, because both of those things together create a runaway process that has a logarithmic response curve.
You're right, like that's wild, and that it will literally create a runaway process reaction.
Yeah, it's definitely wonky. But
So,
okay, so I'm going to show you a tiny little sample, and I don't know how well you'll be able to see this, but
ooh,
I
okay.
will try. Okay, so inside this little jar, yeah, let's see if I can get this to focus. Okay, so inside that little jar, there's some
Oh yeah,
some of
there
this
you go.
like grayish dust.
Yeah.
Now, it's not like uber magnetic, because I did say they were iron rich crenellated nanospheres, but that does not mean they're completely made of iron. They're actually made of a number of different elements, but they do have a high percentage of iron, so they are ferromagnetic, not just simply paramagnetic. And if I jiggle this jar around, kind of like I'm doing right now with my hand, and get those particles
Making
agitated
barrel
so they're
food.
free to move, and I place a magnet underneath, you'll be able to see that it will actually pull them in to the line, and it'll want to stick right around the edge. So if I just I have to take this magnet off here, so I'll lift that up. See if I can show this.
Oh yeah. Oh, just a little lower to the camera. There we go.
It's not a good angle yet. I'm just going to shake it and agitate it for a little bit, and then I'm going to take the magnet away. Okay, so I took the magnet away, and you can see right at the edge where the magnet was, it pulled them all to that spot. And so if I put this closer to the edge, and I did the same thing, now they're all going to be near the edge when I take it away. I'll just wait for that to settle a second. Yeah, now you can see they're pulled to the edge.
Yes, sir.
So it's a bit weird because they're still suspended in water, but that's a tiny amount. Now I have two other jars, and I'll grab those real quick. And these are from my most recent experiment, where the piece of foil that I was showing earlier, those spheres that you're looking at were not from that experiment. They were from the one previous to that experiment.
Nice.
So the lighting is not as good here, but we'll see if we can see it.
Oh yeah.
So in the bottom, there's actually quite a bit of aluminum fine nanoparticles, but you see all that grayish, really dark black stuff. That's the iron crenellated spheres. And I have to separate them out from the aluminum still, but that will be a process that I can only do once I change the pH. The reason that this solution is foggy right now, looks white, is because even though I had drained off all the fluid from the top of this stuff that was left at the bottom initially, it still was reacting, and the EVOs were doing work. So literally after the reaction was shut off for the next several days, the EVOs were still coming out, breaking off the metal and going from the dark mode to the bright mode where they actually react, and they were producing even more aluminum hydroxide by microcavitating the rest of the material in there. So this was filled with huge chunks of aluminum before. It's all dissolved, and now it's this white murky powder in suspension. And this is the drain off stuff that was totally dark gray for days, and tonight during the blood moon it went clear finally, and it dropped off in suspension more of the ultrafine nano crenellated spheres, and they are sitting at the bottom, and you can see them. So when I separate these from the aluminum, I should have a decent little pile that I can send Bob Grenier in a small vial, and I will label them with the date, and I have the video footage of the setup for the experiment, and then he can scan them with SEM and determine what's exactly in them. But the thing is, the process that I use to generate these things and do this transmutation is a process that has never been done so far as I've seen yet, because I don't think anybody just had a 400-watt sonic dismembrator sitting around to play with. Like, a lot of people had ultrasonic bass, but they are not even close to the retarded amounts of energy concentrated at that probe head.
I get you on that. I'm a little bit jealous.
Well,
We're gonna have to talk afterwards of some experiments that I'm gonna require you to run for me.
oh man, I've been yeah, I also mentioned, I suppose, this other thing that I've been using it for. I didn't pull it out to do Ultra. It's just once I had it out, I had already done Ultra in a sonic bath, and I was like, okay, well, I got this for another project. I got it to make a special type of metamaterial for an anti-gravity experiment, or I should say an anti-gravity device that is a solid state, no moving parts device, and operates by similar principles to the Graviflyer, but doesn't have any spinning magnets or that kind of goofy stuff. So, um, anyways, to make the material, I needed to completely micronize a material called chitin, which is usually found in the form of chitosan, and it's derived. Chitin is derived from
Bug stuff.
shellfish. Yeah, shellfish and bugs like shrimp, crabs, um, lobster is mostly what you'll find like commercial chitin sources. They're being sold as chitosan or in that form for. But the chunks, the powders that you get, they're fairly large pieces, and in order to get them to form a very good hydrogel and start to relink protein chains using acetic acid, you have to break them down to the tiniest pieces possible. And in order to do that, I needed the power of the sonic dismembrator to really bust them into extremely nanoscopic sized particles so that they would be able to form a new hydrogel matrix and trap the specific material dopants into that matrix that I needed to interact with the scalar stacked electromagnetic field.
I know exactly what you are doing with that, and that's super cool.
It's going to be a heck of a thing, too, because I finally understand how to do it. It took my brain several years to understand the concepts that my mentor taught me. And now that he's not around anymore, I'm starting to talk about what these things were and what he taught me. And this kind of stuff is it. He showed me how to build these, or well, not showed me in person, but described with reasonably high technical detail how to construct these gravitational panels. And
gravitational panels, exactly what I suspected with that material. And it goes back to, what was the Russian Soviet Gravenko that originally
Grebennikov, yeah.
Grebennikov
discovered that the chitin in a certain type of beetle happened to have the right shaped geometry. Okay, so chitin alone does not have magical, mystical properties. Okay, well, technically it does. Chitin actually is an incredible detoxer if it's properly deacetylated. So, I'm sure I said that word wrong, but it has to go through a process in order to make it useful to a human and not toxic. Otherwise, it can cause other problems. But if it's properly processed, chitin can help you lose a huge amount of weight safely in a healthy way really quickly, because chitosan will go into your body and it will grab hold of, like, each little chitosan particle will surround itself with a layer of fat that'll take out of the body. Like, usually the body has all kinds of fats that are kind of useless to it, and it keeps them around as like an absolute last resort because they're slow to break down, and they would allow you to like fast for weeks if you had them, because they break down so slowly, but you wouldn't be operating at any kind of capacity. So they really don't help us. And a lot of people store around these fats and walk around with these extra fats attached to them. And chitosan will help strip that stuff out of your body if it's not doing any good for you. And it'll leave the muscle tissues enhanced because it also acts as like a little delivery truck for all the phytonutrients that you're consuming. So if you combine it with things like high density multivitamin, or good supplementation of various micronutrients and other minerals and elements that you should be consuming if you're not getting them in your food already, or if you just simply take it in conjunction with meals, then that kind of thing, like it can help your body get that stuff into the bloodstream in a more efficient manner. But
But of course,
besides,
none of
yeah.
this is health advice.
Yeah, it's not health advice. This is just if you go on Wikipedia and you read about the kind of uses that it has, or you go look up like on WebMD, this is the kind of thing that you're going to see it being described for. It'll also warn you, do not over ingest it. You have to actually know what you're doing. You have to have like a medically prescribed dose, and you should see a doctor first, according to all these sites, just to like check out if you're even, you know, if your body is healthy enough to even handle this stuff. So it's not the kind of thing that you should just go, oh, I'm just going to go get that on Amazon, right? And then just start experimenting on myself. Do not do that because you can really mess yourself up or find yourself in the bathroom for half a day or something that you just wish you had never done.
Exactly.
So anyways, chitin on its own does not have any kind of, superior properties. But what Verbinikov found out is that there's this something in nature that causes fields to act weirdly. And it happens when you have something made of a certain shape. This something could be wood fiber, cellulose, or it could be chitin, like in insects, or it could be a variety of other fibers. You could make it out of literally fiberglass. If you wanted to, you could make it out of bamboo. You can just about anything that has a fibrous structure or anything. Technically, you can make it out of carbon nanotubes, and carbon nanotubes actually utilize this. Is one of the reasons why you have insanely high electron drift velocities over the surface of carbon nanotubes, and why the electrons don't actually flow through the nanotubes or jump atom to atom, but they flow as an evanescent wave across the surface, is because of that geometry. They interact very differently with the external space. And Verbinikov found that if you assemble a left-handed molecule, chitin, in combination with a certain geometry, which the beetle naturally had, and then you stimulated it with an electric charge and vibrated it mechanically and displaced it within that electric charge, that it would spontaneously generate its own magnetic field at the atomic scale. And that magnetic field plus the charge end up having a compound effect that puts a huge amount of energy into the localized stress energy momentum tensor and starts to produce intensified electromagnetic radiation that can operate into the terahertz spectrum. And with all that said, basically he found out that if he shakes beetle wings really hard while they're electrostatically charged, and he has a source of ions, which in his case he used the carbon content of coal or a wood ash that was burned and then mixed it with some kind of binder into some kind of plant fiber and coated the inside of the bottom of that as like a negative ion source hooked up to a high voltage pulsed DC power supply. And it was those two things together, the high voltage ion source and then these little wings flapping with their geometric structures under that electric field, that was allowing him to fly around. Unfortunately, Verbinikov, according to legend anyways, or folklore, developed foot cancer as an exposure to what he called lepton radiation.
Really?
Really?
Heard that aspect.
Yeah, and so that's what lepton radiation, which is, it didn't really have a name at his time, so why not call it something interesting? But, this is what Bob Greenyer talks about with strange radiation, where it's a quite damaging type of thing that has a signature of these extremely high energetic self-wrapped electromagnetic fields. It's sort of like the Ouroboros of the electromagnetic world. If you close a field in on itself, then it's somewhat self-sustaining, like a phantom.
Self-sustaining, self-generated magnetic field on the atomic level.
It's a weird thing, man. It's a whole weird thing.
Oh yeah.
I'm sure like most of the stuff that I just said is not going to really serve anybody any kind of purpose or function. It probably sounds mostly like word salad, but I suppose the people that know about chirality and understand things like benzene ring aromatic reactions and that kind of thing, and has looked at Ron Kita's work, might be familiar with these concepts and start to see why things like chitin with a left-handed spin molecule and carbon plus an electromagnetic field and an electric field can produce weird effects. I do have a paper that I'm working on.
Nice.
Which will help clarify these ideas in a much more eloquent way with less unnecessary words, since I'm kind of producing this description on the fly right now.
Hey, I like it. It's real science, and it's how we manifest our understanding and make sense of it, right?
As best we can.
Exactly. So I've been bringing up a few of these different charts and periodic tables in relation to how you're talking about if aluminum makes iron mostly, what bismuth most likely would do. And when looking at the relationship from the Walter Russell main periodic table, here we can see aluminum is on the 6th octave and it's one down from the middle. And then you got iron, which is on the 7th octave and also is one up from the middle, being cobalt there. So going down to bismuth on the 9th octave, being on the outer side there, 3 from center, then you're either going to get actinium or alberton if it does the same up one.
Well, seeing as the rarity of those things, if it did actually up convert in that fashion, then
right?
If it actually did, like, nobody is going to say, well, that's strange, this must just be contamination of these ultra rare metals in the business that would never occur otherwise.
Right, so now you're gonna have to do it and see if you can produce some alberton for your Albertan friend BurnEye here, right? So
yeah, I don't think I've ever even said actinium out loud for any reason. I don't think I've ever had a need to. So.
Right, or some actinium.
It is a cool name to learn, though.
Hey, we'll start producing it, and we'll have all the reason in the world to keep saying it.
Yeah, then we can, get into the whole territory of, I wonder what I can screw with next.
Oh, yes. Gotta love the mad scientist reality when you find a glitch in the matrix. So I believe this was also a Walter Russell diagram, and it's very similar to the Scenario Arrow Club diagrams.
That is interesting. Where did this come from?
These are all Walter Russell diagrams.
Huh. Did he have a label on that one of what he was trying to describe with it?
I don't see it saved. I will have to look into it and find the original for you for it.
Yeah, I wonder what he was trying to represent with that.
There's so many.
Yeah, one thing no one can take away from the man is that his drawings were absolutely gorgeous.
Right? So before their time. And it's like he's the original theory of everything. Connecting sound, light, atoms, motion, energy, spin, octaves, charges, density. Oh, plutonium. So he called it something else before they were actually discovered or invented, I guess. Named.
Yeah, I think when I have to print out some of Walter Russell's elemental charts.
Oh, yes.
Just to kind of determine like which things I want to test next.
Right? There's so
I mean,
many. And
because if I gotta send Bob stuff up anyways, I mean, and ship it all the way out there, I might as well include some samples of different metals as well, because that's stuff that he hasn't looked at yet, and it could be kind of exciting for him to get that in the SEM and figure out what the heck is happening there. Just to know that the same
absolutely.
process was used on two different things, it would give us a heck of a lot more data than we have right now.
I fully agree and look forward to seeing what you come up with and the results. And here's another Walter Russell periodic table diagram that is vortex based, that is not so well known. Very fascinating stuff. Oh, you're muted, Jeremiah, if you're trying to talk.
Yes, indeed. I was not trying to talk. I was just actually looking at that chart, that spiral chart, and I was wondering where aluminum and iron sit on that chart to see how he represents that.
Those were the noble gases, I believe. So, no, so there's iron down there. So yeah, they're just further out. Oh, see there, we got bismuth and iron and isotope. Oh.
Yeah, so where's aluminum?
Is it? I think it's on this side potentially, or no?
Oh, I think there it is. I think aluminum is like the thing that's covered up by tritium.
Yeah, aluminum right there.
Okay, so
I think so.
let's scroll back down to iron again. Let me see where that.
Iron right here.
Interesting. Yeah, it's not directly. It's not directly across, but I don't know why aluminum is stopping at iron, or why it tends to prefer that. Not a clue. That's probably a question more for Bob.
Or still to be discovered and answered.
Indeed.
And
then the other question that people were asking too, which I should probably at least address, is in my experiment, how do I know that it's iron and not just some isotope of aluminum that happens to both change the color to being identical to that of iron, but also, could aluminum become somehow ferromagnetic if a certain number of neutrons were removed or added? The thing is, I actually don't know. I have no idea if some of the isotopes of aluminum are magnetic or not. I suppose it's possible that it could warp the shape of the electron shell enough to do that. Not really certain though.
So here's another periodic table that he has in the arch octave breakdown. Oops.
Yeah, I've just got to get a copy of all of these.
Right?
I might even have them on my computer somewhere. I should probably jump off though,
maximum stability. Yes, we are getting to that time of around 2 hours as it is, because I need to end it so AI can generate a bunch of clips out of this.
Namely though, it's also that 3 o'clock is about to roll around, and I need to go step outside and howl at the moon. And I was telling people earlier, as the Earth, Earth's shadow covers the moon, we're losing all the blues and the greens and everything else that's of the violets there of the higher wavelengths being pushed off at other angles, right? So all you're seeing is the reds. And I was saying, just stare up at the moon tonight and imagine that it's just washing all your blues away. So because that's photonically exactly what's happening. So I'm gonna go outside at 3 a.m. and howl at the moon.
I'm going to do the
release
same.
my worries.
Great advice, brother. Great science updates. Thank you for joining, and thank you everyone for watching, and we'll be back again soon. Happy Wormwood Moon to all of you, and go wash the blues away with the blood moon. Ta-ta.
Laser.
You crazy mother. Yeah.
It's just burning.
Hey, Bernie, just like last week,